All right. Hello, everyone. Welcome back to my channel. Today, we are going to be talking about limits, which is a topic from Calculus 1. And we're specifically going to be taking a look at this problem from the March 2009 comprehensive exam. And it is question number 1. So the limit that we are trying to compute is the limit as x approaches negative infinity of this expression right here, the square root of x squared minus 4x plus x. Now, because x is approaching negative infinity, which is obviously not a real number, this is essentially saying as x is growing without bounds and is a negative number, right? Because that's not a real number, we can't just plug in negative infinity, right? Because what would we get? Well, for the square root, right, of negative infinity squared, that's just the absolute value of infinity, right? So that would give us infinity, and then plus the negative infinity would give us minus infinity, right? So this is actually does not exist. So a lot of people, when they see this, they might think, oh, it does not exist, or it's infinity. That is not true, right? So this is actually not true. This is an indeterminate form, and we have to use L'Hopital's rule or some other trick to get this into a nicer form where we can actually compute the limit. So we're actually not going to use L'Hopital's rule. We are going to be using a very clever trick, and whenever you see something that is the difference of two terms and one of those terms has a square root, that is a very good sign, or a strong sign, I should say, that we're going to be using the conjugate. So in this specific instance, we're actually going to multiply this expression by the conjugate over itself, which we know is 1, right? And so that's actually not going to change the value of this limit. Minus x over itself, right? So that the value does not change. X squared minus 4x minus x. And because this is one term plus another term, the conjugate, we just turn that plus into a minus, right? If there was a minus there, the conjugate would be a plus. They're conjugates of each other, right? And so what that will give us is the term squared, the first term squared minus the second term squared, right? Because we know how to multiply binomials. So that should just be this whole thing squared. We just eliminate the square root and we get this, right? Minus 4x. And then minus x squared, right? And then on the bottom, everything stays the same. That's just going to be negative x squared minus 4x, the quantity in the square root, and minus x. So we can see, right, immediately that two things are going to cancel here, right? So this is going to cancel with this, right? And what we're also going to do is we're going to try to factor out an x squared from the thing inside the radical. And I'll show you why we're going to do that. And you might not immediately think to do that, but you'll see in a second why we're going to, as I said. So this is still the limit as x approaches negative infinity, but on the top we now have negative 4x, right? And then on the bottom we have, right, x, the square root of x squared times 1 minus 4 over x, right? Because we're factoring an x squared out of both of those terms, minus x. And we know, right, that the square root of x squared, right, is just the same thing as the absolute value of x, right? So we can actually use this to make a substitution. However, absolute values are kind of nasty to compute. So we can actually use the definition of an absolute value, right? So this is actually equal to negative x if x is less than 0, right? And then x if x is greater than or equal to 0. So we see, right, that the values of x are approaching negative infinity, right? So with this limit, we actually really only care about the negative numbers. So what substitution are we going to use for the absolute value of x? We're going to use this, right? Because this is the substitution that we make when x is less than 0. So really what this is going to turn into, and you have to be very, very careful, right? This is where they try and trick you, and this is what makes this problem difficult, right? Because limits aren't so tricky on their own, but things like this, there's going to be things that they are purposely trying to stump you on. When we factor that out, you are going to get a negative x, not a positive x. So remember, the square root of x squared is not just x, right? It is the absolute value of x. So minus x. And now we have an x in every term, and therefore we can cancel it out, right? So basically what's going to happen is this, and this are going to cancel, and we're going to be left with, the limit as x approaches negative infinity of -4, right, over negative square root of 1 minus 4 over x minus 1. Right? And what's going to happen? Well, as x gets larger and larger, right, in the negative direction, I guess, this is going to cancel out, right? Because the x is on the bottom. So when the denominator gets bigger, that whole thing is going to go to 0. And we know that the negative square root of 1 is simply just -1. So this is going to just equal, and we can finally drop the limit because we plugged in our numbers, -4 over -1 minus 1, which is just 2. And this is our final limit right here. Awesome. So just to summarize, we multiplied by the conjugate over itself. We can kind of tell that we're going to need to do a trick similar to this because we got an indeterminate form, right, at first. Also, when you see the sum or difference of two things, especially when one of them is inside of a square root, that is a great time to use a conjugate. The other tricky thing is we factored an x squared out of this term inside the radical, the radicand, and we had to cancel that out in a way that is not as trivial as you might think, right? Because our values are negative, we have to substitute it with -x, not just positive x. Awesome. So yes, as always, if you have any questions about this particular problem, feel free to let me know, and I will see you in the next video.